Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So we are starting with the module 2 of this course. So this is the lecture 1 of module 2. And in this lecture, we will be discussing from messy problem to agent system. So let us look at the lecture overview, like what this lecture is about. So see, most practitioners, they don't begin with a grand design document. Because if we talk about most developers, they start with some basic idea, a messy workflow. So they start with a messy workflow, an overloaded team, a vague idea, an API key, and a problem that needs automation. So most of the practitioners, they start with a problem and then they will not put efforts in perfect design. Rather, they will straight away experiment the messy workflow. They will be utilizing their overloaded team, vague idea, and API key. If we talk about agent systems, they begin with, so in agent systems also, so the idea is that when you are building agentic AI application, in that scenario also, you should not put much effort in planning. Like the scope should be, you should start with a very limited scope. So the idea is in agentic AI application, we should start developing it with a messy problem and a rough idea of what might help. Because if you begin with, let's build an agent, you will end up over engineering. Because see, agents are something which are very new to us. Because traditionally we have been building web apps, mobile apps, but building agents, building agentic AI application is, it's completely different. And if we straight away start from thinking that, okay, let me build customer support agent, let me build that agent, this agent, then you will over engineer the solution. Because in building the customer support agent, you might end up adding so many unwanted features. So the right mindset. So whenever you are building agentic AI application, rather than focusing on what kind of agent you want, focus on where you want automation, the workflows. So you look into the messy problem and start with a very rough idea. Just implement that and then keep on evolving. So the idea is whenever we are building agentic AI applications, we have to begin with what repetitive cognitive task is ripe for automation. So I have to identify, okay, what is the repetitive task which can be automated. So I should automate that. And if I just find the repetitive cognitive task which can be automated, and if I just automate it via using agents, then I will build something useful which will have value. So that's the approach. And that is what this lecture is about, from messy problem to agent system. So this lecture will be very useful for you in such a way that it will give you a mindset that, okay, when you are starting to build a agentic AI application, how to begin, how to start with it. So you have to start with a rough idea, like you have to begin with by identifying the cognitive task that can be automated, and you just have to automate that. And you have to keep on iterating, keep on adding more features. We call it iterative design. So all this we will discuss. So this lecture is about that mindset. So if we look at the topics that we will cover in this lecture, we'll talk about an example of the e-commerce support, the e-commerce customer support example. Why does agent design start with a messy problem? Identifying automation boundaries, carving out the right slice of workflow, deciding what humans do versus what agents do, converting business workflow into agent workflow. The tool calling workflow pattern. Why this example is so important? So the e-commerce customer support example. And finally, we will conclude this lecture by discussing design philosophy takeaways. So all these topics we will be covering in this lecture itself one by one. So this is the module 2, designing agent systems, lecture 1, from messy problem to agent system. And we are starting with the first topic of this lecture, the e-commerce support, the e-commerce customer support example. So let us suppose, imagine that you are running an e-commerce platform. So you are selling something online. So you have an e-commerce platform wherein you have listed your products, your inventory. Users, they can visit your online shop. They can scroll through the products. They can search it. They can know about more about it, and then they can keep on adding the products that they want to buy on their cart, and they can proceed with a checkout, and they will fill in their details, address and all that, delivery address, and after successful payment, that order will be delivered to you. That is the like a basic flow of an e-commerce platform. Now in the real world, this e-commerce platform, it will face many issues. So every day your support team will handle issues like refund my broken mug. So this kind of a complaint you might get, wherein a photo of broken mug was attached, and the customer claims that he received a broken mug, so he want refund for that. Or the customer, he might want a customer support for canceling order, cancel my order with the order ID, or change my delivery address. So what is the manual process of handling those concerns? The current manual process of handling those concerns. So we have human agent in place, like the customer support executive, we can call it. So on a daily basis, he is receiving support requests like the one we just now discussed. So what he does is that he will first read the email, and in that email he will get to know about the concern. Then based on the concern of the customer, he looks up the backend for the order. So he looks up order in the backend. Then he calls the appropriate API and then sends the confirmation message. Like what the customer support executive here is doing is like we are taking a slice, a very small manual routine cognitive task with a fixed set of procedure, with a fixed set of tasks. Like let us suppose a human agent manually to verify the concern, whether the concern is valid or not. He is following a process. First he is getting to know about the concern by reading the email. So he will read the email. Then the customer support executive, he will look for the order. He will check whether the order exists or not in the backend. Then he will call the appropriate API to get the details of the order. And then he will verify manually that, okay, whether whatever the concern the user has raised, whether it is valid or not. And then he will send a confirmation message that, okay, uh, we have considered your concern, it is under processing, something of that sort. So this is a manual task. Now the problem with this manual routine cognitive automation, the problem is that if the e-commerce platform is very big, it can receive so many requests, and on an average, it takes around 2 minutes per ticket. And if you multiply it by hundreds per day, then it will be a bottleneck because it will be infeasible for one customer support executive to handle all the requests. So this routine automation cognitive workflow, we can introduce agent to automate it. So here agent design, like we can design an agent which can replace a human agent, like which can automate this. And when we will be designing agent, very important discussion I'm making. So now it's very clear that okay, we are looking at an example of an e-commerce platform. There we identified a workflow which involves some repetitive cognitive task which can be automated. We identified that. Now we will design an agent for that. So when we will be designing agent, we will not at all think about intelligence, because hypothetically, when I am designing agent, I should think big, that oh agent, it can do this. But no, whenever we are designing agent, let us be very simple. Let us not at all think about intelligence. Rather, let us think that how we can automate the workflow. And we have to identify the repetitive decisions and execution patterns. So that's the idea. So whenever we are designing the agent, rather than thinking big, thinking about intelligence, we have to think about the workflow. What is the exact workflow? We have to identify the repetitive patterns and execution patterns, because those patterns will help us in designing an efficient agent. Because if we think about intelligence, we may end up over engineering, and the problem which we are trying to solve, we might drift away from that. So now it's very clear to us. So this example gave us a very clear picture that okay, whenever we are designing uh, agent AI applications for a messy problem, we have to first understand the messy problem, and we have to find the workflows which can be automated. And we have to start by designing agents which just have to automate that workflow, nothing else. And then slowly we should keep on iterating, adding more and more features. So that's the idea. Why does agent design start with a messy problem? Okay, so this is very interesting. So the idea is that why agent design start with a messy problem. So see, if we talk about real business problems, real world business problems, if we talk about, they are messy by default. By default, they are messy. And why they are messy? Because they are unstructured. Real world business problems are unstructured. They often lack a predefined format or schema. They are ambiguous. The goals and requirements are frequently unclear or open to multiple interpretations, requiring clarification and reasoning. So real world business problems, they are highly unstructured in nature, they are ambiguous, they are inconsistent. So data and human inputs can be contradictory, or they can vary significantly in quality and detail. Like in real world business problem, the requirement might not at all align with the data provided or the input provided. So that is the inconsistent. Real world business problems, they are human written. So they are expressed in natural language with all the idioms, errors, and subjective nuances. Because real world business problems, they are articulated by humans, and real world business problems, they're context dependent. Meaning and priority shift based on the specific situation, history, or stakeholder involved. So now it's very clear to us. We got a idea that okay, real world business problems for which we will be building solutions, for which we will be building agentic AI application, it will be unstructured, it will be ambiguous, it will be inconsistent, it will be human written, and it will be context dependent. Now we have been discussing this from the very starting of this lecture, of this course, basically of this course, that agents, they can adapt. Agents are not brittle, rather they are flexible, because see, traditional softwares, they were rule based. We had fixed workflows, so any uncertainty they used to break. But agents, they are not rule based. They can adapt. They are very flexible. Rather, they generate dynamic workflows. So agents, they can very easily handle uncertainty. And because of that, agents are uniquely suited for such kind of real business problems, which are unstructured, ambiguous, inconsistent, human written, and context dependent. Because see, when you are trying to build a traditional software, then first what you have to do is you have to convert the messy problem into a structured problem, wherein all the ambiguities, inconsistency, context, structure, that you have to, like, humans have to put effort to make a messy problem, to convert a messy problem into structured problem, and then build a traditional software for that. But when we are designing agentic AI application, no need for us to put extra efforts in converting the messy problem into a standard structured problem. Because by default, agents, they have this capability of handling the nuances of real world business problems. Because if I talk about agents, AI agents, they can interpret free text. They can understand the natural language and they can very easily interpret the free text. They can make decisions on their own. So they can interpret the free text. They can identify that, okay, what the problem is and what the solution they are looking for. And it can make an action plan. Agents can on their own make an action plan. They can take decisions. They can call tools. They can even execute actions. They can call tools and they can generate responses. So agents, since they are very adaptable, flexible, so very easily they can handle real world business problems. And hence agent design start with a messy problem, because agents, they can interpret free text, because agents, they make use of large language model, and we know that using large language models, agents, they can extract meaning and intent from natural language. And traditional softwares or traditional automation, which is rule based, rigid workflows, it fails here. And why it fails is because if we try to, like, code rules, then rules can explode in complexity, because we cannot handle all the scenarios. The real world is so uncertain, we cannot handle all the scenarios. We cannot write rules for all the scenarios. We cannot write rules for all the possible scenarios. So traditional automation, it is like rule based, so it explodes in complexity when it comes to solving real world business problems. It fails under edge cases. So in the real world, the unusual happens frequently, that hard coded systems are constantly breaking. And when, like, the traditional automation, when it deals with real world business problems, hard coded workflows, it start becoming brittle, it start breaking. So the idea is agents, they thrive in semi structured chaos. Agents, they thrive in semi structured chaos. And hence agents, like, whenever we are designing the agentic application, we have to start with a messy problem, identifying automation boundaries. So now it's very clear to us that, okay, whenever we are designing an agent, so the first design decision is not about how do we build the smartest agent. Rather, it is about what part of this workflow should we automate. Like, the messy business problem we are considering, we have to identify the repetitive cognitive task which can be automated. So what part of this workflow should we automate, that we have to decide. And also very important boundary we have to set, that we should not try to automate everything. Not everything should be automated. So let us suppose in a business problem, there are so many scenarios which can be automated, but we have to start with a basic automation. We have to start with automating like a basic workflow, and we should keep on iterating. So if we look at an example to understand it more clearly, let us look at an e-commerce example. The same example which we saw in the previous slide. So what can we automate in the e-commerce example, which is safe and repeatable? So we can automate order cancellation. So let us suppose the user wants to cancel an order. Now order cancellation, it requires a repetitive cognitive task, and very easily we can automate that workflow. Refund initiation, it also follows like a fixed set of patterns. We can very easily automate it using agents. And address update, let us suppose the user wants to update an address, we can automate it using agents. In the e-commerce example, what we should not automate, because it can be complex or risky to automate that. So we should not automate complex disputes. See, the idea is that whenever there are complex disputes are there, let human customer support executive handle that complex disputes. Let us not bring in, let us not over rely on agents, because agents, they can hallucinate, they can make mistakes. So complex disputes should not be automated. Rather, complex disputes should be taken care by humans. Legal escalations. So anything legal is there, that should be taken care by human agents, and we should not automate that. And high value fraud cases, like let us suppose we have billing of lakhs. So high value fraud cases should not be automated. Rather, it should be given, it should be the responsibility of human agents. So with this example, I hope you got a very good understanding that, okay, any real world business problem you are dealing with, you identify the complex and risky scenarios. Because see, always remember that agents, they can make mistake, they can hallucinate, they can get confused, they can make mistake. That's why we should not over rely. So all the sensitive tasks, sensitive workflows, which is of high value, which can be risky, complex in nature, we should not automate that. Let humans take care of that. And whatever safe, repeatable workflows we have to identify that, and only that we should automate. So now it's very clear. So with this, we got an idea about the automation boundary, that okay, automate only the safe, repeatable, rule constraint slice. So rule constraint slice is very important. The workflow should be constrained with a rule. Like the workflow should follow a fixed rule. It should be repeatable. It should be safe. Because if you try to automate too much automation it can lead to risk increases. We already saw. Like if we try to automate complex disputes, legal escalations, high value fraud cases, then the risk will automatically increase. In legal escalation, what if agent makes a mistake? It can be a disaster for the e-commerce platform. So as we move into high stakes, low frequency scenarios, the cost of a mistake, especially in the legal, financial, or reputational domain, often outweighs the efficiency gained. Too much automation, if I talk about, reliability drops. Because see, AI agents are probabilistic in nature, they are not deterministic. So the more exception handling you offload to an agent without human oversight, the more likely the system is to drift from the intended goal. Because see, too much automation, we know that agents, they can hallucinate because they're probabilistic in nature, they can make mistakes. So too much automation means we are over relying on agents, and hence the reliability drops. And too much automation, complexity explodes. because trying to build a system that handles everything leads to a massive prompt change and logic trees that are impossible to debug or maintain. And if we go for too little automation, so for too little automation, the ROI, return on investment, is weak. If the automation only handles the most basic 5% of the task, the human staff still spends the majority of time on manual work, then what's the point of using the agent? The overhead of maintaining the software might actually cost more than the labor it saves. So too little automation is also not good because we will be wasting resources. So the return on investment will be weak and efficiency will be low. So we have to set a balance, and that's what this topic is about: identifying the automation boundaries, wherein the business problem you are trying to solve, you are trying to build an agentic AI application for a business problem. You identify the workflows which are safe, repeatable, and rule constraint, and you avoid workflows like the repetitive cognitive tasks which are complex and risky. We should not go for too much automation, we should not go for too little automation, so a balance should be there. So one very important point: agent agent design is about slicing carefully. Agent design is about slicing carefully, carving out the right slice of workflow. So if we talk about the right slice or the ideal slice of the workflow, so what it means is that, okay, in the business problem, we have so many workflows which can be automated. Now we have to find the right slice which we should automate. So the ideal slice, it is narrow. It is narrow enough to build quickly. It should not be broad. It should be narrow enough so that we can very easily build it. Valuable enough to justify effort. Rich enough to demonstrate intelligence. So in the example of e-commerce, the slice we took is take raw customer message plus order record, decide which tool to call, execute that tool, and send confirmation. That's it. So see, the idea is like in the example which we are discussing in this lecture, we are taking an ideal slice because that is very narrow, valuable, and rich. Because just 4 steps we are doing. Like we are reading the email, and from that email we are extracting the raw customer message and the order record. Then we are deciding which tool to call to resolve that concern. Then we are executing it, and once the goal is achieved, where the concern is resolved, we'll send the confirmation message. So notice what we did not include. So we did not included long-term personalization. Like we kept it very narrow in that sense that, okay, user sent the concern, we resolved it, close. We are not at all maintaining the context, like long-term personalization we are not keeping. No learning loops are involved. No multi-agent collaboration. Only one agent is handling the entire workflow. So no multi-agent collaboration. No complex reasoning. So it's very clear that, okay, whenever we are designing agents, we have to start small always. Because the idea is, once the basic flow we have implemented, once the basic flow we have implemented, now we can keep on adding more features to it. Like now we have a agent which is solving a problem, which is able to resolve the concern of the user. Now we can think, we can innovate. In the second version, we can add more features to it. So that we call it the iterative design. So now it's very clear that, okay, whenever you are designing agentic AI application, don't start big. Don't think about building the smartest agent. Rather, identify the workflow. Try to find the ideal workflow, ideal repetitive cognitive task which can be automated. So it should be safe. So identify those workflows and just automate that so that you will have agents which are solving a problem. Then you can further innovate it. Deciding what humans do versus what agents do. So this is one of the most important system design decisions. Like we have to decide what humans should do and what agents should do. So we have to ask a question like what requires human judgment. So whenever we are talking about ethics, nuances, or empathy, there human will come into the picture because humans they have to handle ambiguous cases. So whenever any ambiguous case is there, let humans handle that. Emotional escalations should be taken care by humans. Policy exceptions, because in such scenarios, agents might hallucinate. Because see, agent is trained, it is given all the policy rules. But what if it encounters policy exceptions? What if the system encounters policy exceptions? In that scenario, since agent is not trained, it might get confused. So it's better to bring human in the loop. So whenever the system is encountering ambiguous cases, emotional escalations, or policy exceptions, let humans handle it. Let humans handle it. And if we talk about what agents should do, so we have to find clear patterns. So wherever clear patterns are there, agents should do that. Like logic, speed, data processing. So when we need speed, logic, and data processing, let agents come into the picture. So agents, they should handle intent recognition, like reading intent, selecting correct backend action, executing API call, sending structured confirmation. So all this should be handled by the agent. Reading intent, selecting correct backend action, executing API call, sending structured confirmation. So the agent becomes a decision plus execution accelerator. So now it's very clear that see, agent, he will be making the plan. Agent will be making the plan. It will be deciding the set of actions that needs to be taken. And agent will also be taking care of the execution. So agent will become the decision plus execution accelerator. And agent will never replace human, not a replacement for human oversight. Now we have set a clear boundary. Now the boundary is very clear that okay, whenever we are designing agent AI application, let so first you identify the ideal workflow which should be taken care by agents, and agents will not work fully autonomously. Like in that workflow also, if there is some ambiguity is there, some emotional escalation is there, policy exception is there, let human come into the loop. So that's the idea. So decision and execution, let agent take care of that. Let that is the autonomy. We talk about autonomous AI agents. So the autonomy, like agents have the freedom to make the plan, decide the set of actions, decide the tools which should be called, and orchestrating the execution. That agent should take care of. But human oversight will always be there. Wherever agent gets stuck, human will come into the picture. And this division is very important because it builds trust. Because now humans, they will have confidence that okay, agent still they are working under their supervision. So this division, it builds trust and reduces the risk. Converting business workflow into agent workflow. Okay, now this is very interesting. So see, one more very interesting technique you can follow, like when you're designing an agentic AI application, you first identify the ideal workflow. then you see how humans are following that workflow and try to replicate it. So we call it transforming the original human workflow into agent workflow. So whatever ideal workflows you have identified, which you are planning to automate, you try to find the original human workflow for that. For example, in our example, the human workflow is read email, then interpret the request, then look up order, decide action, call the APIs, send confirmation. So this is the human workflow. Now we have to transform it into the agent workflow, wherein read email means receive raw message. Interpret request for agent, it will be parse the intent. Lookup order for agent, it will be select correct tool. Okay, so lookup order, decide action, and call API. So these three for agent, it will be select correct tool and call tool with parameters. And send confirmation for agent, it will be generate confirmation message. So what we did, the human workflow, we transformed it into the agent workflow. And this will make it very easy for you to design agentic AI applications, because see, now we are agentic AI application is something very new for us. We have never done such kind of an app development before. So it is more about the mindset, and that mindset we are learning. And also this is where agent systems, they differ from chatbots, because agent systems, they can automate the workflow, because see, chatbot, we already saw that it can only reply, but an agent, it can take actions, so it can automate the entire workflow. Like for this example, the like agent was given the free text, it will make a structured decision, it will invocate the tools, it will get the result, it will generate the response. And this is the core pattern of modern AI agents. This is the core pattern of modern agents. The tool calling workflow pattern. So, like a pattern we are discussing, it's like a generic pattern. You should follow it. So, whenever you are designing an agent, this pattern you should follow. So, step one is all about understanding the input, because agent, it will be perceiving the environment, perception will be there, it will be getting input signals. So, what agent must do is that the agent must read the free from text, extract the intent, and identify the relevant parameters. If we talk about an example for this, let us suppose agent received a message that, hi, I ordered mug with order ID this, but it arrived broken. Please refund. So this is the raw message. Now, while understanding the input, agent should be able to extract the intent. So the intent here in this message is refund, and the order ID is A123. And the good thing is that agents, they make use of LLMs, and LLMs, they are very good. Like the foundation models, they excel in intent recognition. So we just have to feed the raw message to the LLM with a prompt, with a proper prompt that extract the intent and identify the relevant parameters from the given message. It will do it for you. So it will return the response of the LLM will be the intent and the relevant parameters, and here it is the order ID. So step one is understanding the input. Then step two is select tool, because now agent, it got to know that, okay, customer wants to refund, customer wants refund for this order ID. So like when you're designing the agent system, there itself you will pass all the available tools to the LLM, because the LLM, it will know, or agent will know that, okay, what kind of tools are available for it. Like we will have a tool called cancel order. It is a function which will cancel the order. We will have a tool called issue refund, and we will have a tool called update address for order. Now the agent must decide which tool to call. So the agent must decide which tool matches this request. So tool selection cannot be random. So the tool selection is not random. It is a reasoning step, and agent, they make use of the LLM in deciding which tool to call. If the intent is refund, LLM will say that call the issue refund. So here one very interesting thing is happening. Instead of following a fixed, like a pre-written logic, if else logic, the agent, it maps intent to the capability, and based on that it will select the execution path. So in the runtime, agent is interpreting the intent based on the user message, and it is mapping the intent to the capability, and based on that it is selecting the execution path. Step 3 is the execute tool. So once the agent is aware of the tool which it should call, then it will just execute that tool. So what agent will do is, so let us suppose issue refund, it is an API. So agent will hit that API with some parameters. So agent, when it will hit that issue refund API, it will pass the order ID and some other relevant information which API wants the parameters. So it will call the backend API, and backend API will generate the response, and agent will generate the response. So this is like a very crucial step wherein agent is executing the tools. So this is where intelligence meets infrastructure, because some actions have been taken. And if the response is success, then agent, what it will do, it will generate a confirmation message for the human, for the user, for the customer. So finally, the agent translates the backend result and generate a user-facing response. And the example for that can be your order A123 has been refunded. You will receive the confirmation shortly. So this the complete workflow, like the 4 step: understand input, select tool, execute tool, generate confirmation. It is basically understand, decide, act, respond. Understand the input, decide the action plan, act means execute, and respond. And that is the minimal viable agent you can get. So now I hope you got a very good understanding of how to design agents, simple agents we are discussing. Why this example is so important? See, definitely the example which we have looked into, it has given us a very good conceptual clarity about how to design agents in agentic AI application. Because this simple system, the example, it demonstrate model selection matters, because we know that okay, agent will make use of LLMs in intent recognition, in identifying the right tools, in generating the confirmation message. So model selection matters. So if complex task is not involved, no point of using complex models like the GPT-5 or 4. We can use a SLM, small language model. This simple system, it demonstrates tools matter. We should have right set of tools. Orchestration matters, and scope control matters. So now it's very clear to us that okay, whenever you are designing an agent, now it's very clear that we should not think big that I have to design the smartest agent. Rather, the business problem, I have to identify the ideal workflows. Let me identify the ideal workflows, and then I have to implement that, automate that, and for that I have to focus on model selection, tools. I have to have right set of models, right set of tools, orchestration, and scope. Scope is very important. There should be a clear boundary. Like I should not over engineer. and there should be boundary between what agents should do, what humans should do. So this example, it also shows something very critical. You do not need multi-agent systems. Yeah, so it is very clear that we should not start straight away from multi-agent systems. Rather, we should keep the things very simple and we should evolve. And then later on, if we feel like, okay, system is becoming complex, then you should go for multi-agent systems. You do not need complex memory and you do not need reinforcement learning, because all this will come into the picture as you keep on upgrading. So now very important design principle that you should keep in mind whenever you are designing agent or building agent, you have to start narrow. It should be simple. It should be just automating a very narrow workflow. Design philosophy takeaways. So from the e-commerce customer support example, we extract some very interesting principles which are applicable for all the agents you design. So when you're designing agents, the design philosophy which you should consider is start with a real workflow, which is simple, which is safe. So start with a real workflow and just automate it. Automate only repeatable slice. So automate only repeatable slices. And you should avoid edge case explosions. And also when you're starting to design the agent, not never consider an abstract idea. Start with a real workflow, the business problem you are trying to solve, identify the workflows which you can automate, which are not very complex, which are safe. So identify that workflow and automate only the repeatable slices. Not everything can be automated, and avoid edge case explosions. Then we should convert human process. So the idea is that we have to figure out how humans are solving that problem. We call it the human workflow. So we have to convert the human process into, so the human workflow, we have to convert it into the agent workflow. So what we have to do is interpretation. Interpretation means understanding the input and identifying the intent and the parameters. So that's the interpretation. If we have to interpret the problem, then we have to decide. That we call it like the decision. Decide what needs to be done. Like I know that, okay, this is the goal I want to achieve, because interpretation means identifying the intent. So the agent will decide, like it will make the action plan to achieve the goal. Then action will be executing that action plan. Like agent identified the set of tools. It will execute that tools, call that tools, and it will generate the response. So based on the uh, results, the outcomes of the execution, agent will generate a response. Then we should think in tools, not prompts. This is very important. See, the idea is that, okay, we know that what goal needs to be accomplished. So agents, they should try to identify the right set of tools that needs to be executed, and also the order in which those tools should be called. So that is the mindset we should have. We should think in tools, not prompts. And to call the tools, we can think about the prompt. We can optimize the prompt. Selecting the right tool and the order of calling the tool is very important. That should be the first step. And once you do that, then in order to call the tool, you have to prompt the LLM to generate some parameters, some API calls and all that. Then you can optimize the prompts, because agents, they are action systems. So when the agent is planning, it is deciding how to achieve the goal, it will identify the right set of tools, the order in which the tool should be called, and we have to keep things very simple. The version one should be very small, and slowly you can expand it. Like with every subsequent version, you can keep on upgrading it, enhancing it. expansion will come later. So these are like design philosophy takeaways while designing agents. So finally, we completed this lecture. So in this lecture, we learned that agent design starts with messy real world problems. We looked into a e-commerce customer support example. It demonstrated a minimal viable agent. We saw automation boundaries must be defined carefully. We also looked into the real world business problem we are trying to solve. We are trying to build a agentic AI application for that. We have to identify the ideal workflows. Ideal workflows are the one which are narrow, safe, simple. And we also saw that the business workflow, the human workflow should be converted into agent workflow. And how we can do that? We have to identify the intent interpretation, tool selection, tool execution, response generation. So I hope you got a very good understanding of the concepts that we covered in this lecture. So do subscribe to our YouTube channel ScaleUp University for more such interesting lectures and courses. Thanks for watching. Thanks for your time.